In this video, we are going to talk about vectors. Let's first begin with defining a vector. A vector is a quantity that has both magnitude and direction. A vector is represented by an arrow, whereby the length of the arrow represents the magnitude and the arrow itself represents the direction of the vector. For example, if a vector has a magnitude of 10 units, for example, this should have a longer length compared to a vector which has a magnitude of 5 units, for example. There are some other quantities which are not vectors, they are scalars. For example, mass, length, distance, temperature, speed, power, and so on. So they do not have direction. But other vectors, such as other quantities which are vectors, such as displacement, velocity, acceleration, force, momentum, they all have direction. So let's have a look at the example below. Let's say I have just moved an object, a mass, 5 meters. Is my measurement of 5 meters is a vector or a scalar? As you see in this example, there is no direction. So no direction. No direction is mentioned, therefore it cannot be a vector. So this is a scalar. So this measurement is a scalar. Vectors have some properties. For example, vector A and B in this figure, as you see, if they have the same magnitude and if they have the same direction, they are said to be equal. So they are equal. For example, vector A here is equal to vector B because the direction is the same and the magnitude is the same. In this case as well, for example, here vector A is equal to vector B. And vectors have another property. We can just move vectors as much as the quantity, the magnitude and the direction they don't change. We are not allowed to change the length of the arrow or vector, or we are not allowed to change the direction. If we keep this both constant, we can move from left to right and right to left. There is another property, property number 2. Vector A and vector minus A have the same magnitude but are in opposite direction. So if we have vector A, for example, in this case, if we multiply it by minus, so this minus changes this direction of the vector in a opposite direction. So if it is, for example, towards right, it should, when we multiply it by a negative or by minus, it will be to the left. If it is to the left, it should be to the right. If it is towards up, it should be towards down. If we multiply it by a negative, so it will change the direction to a opposite side. Here, the most practical part of the vector properties, is adding vectors. We have a technique called head to tail method or technique. Head to tail, or some they say tail to head. in this method, if we have two vectors, vector A and vector B, and we want to add them, and if we are asked to show vector A plus B graphically, we can just simply place the tail of vector B to the head of vector A. So it will be like that, because head to tail, head of A, this is vector A, and this is my vector B. Then, if we look carefully now, we have one tail and we have one head. Then we just throw a vector from the tail that we have got to the head, and this will be our resultant vector, or vector A plus B. This will be our resultant vector. So in another case, for example, case number 2, if one vector is due east or to the right, and the other vector is due north or to the north or towards up, okay? So how about this? Again, we will use head to tail method. So we have vector A and we place vector B here, because we need to connect tail to head or head to tail. Then we start from tail that we have got here to the head. So we have one tail and one head. So we connect the tail to the head by an arrow, and that will be our resultant vector A plus B graphically. Another case, what if one vector is in opposite direction? So again, the same method, the same technique. Vector A, and again head to tail or tail to head, and this will be my vector B. I will draw it with a different color. So then we should be careful here, because we should keep track of where the head is and where the tail is. So in this case, for example, our tail is still the same tail of vector A, but the head has changed. So this point is our new head. Again, I will connect vector the tail to head, and this is gonna be my resultant vector. So this will be A, vector A plus vector B, this red vector. Another property which is about subtracting vectors, how to subtract vectors. Well, in vector quantities we do not subtract, we always add. But what if we are asked to subtract? So in this case, I will write vector A minus vector B in this way. I will write it like vector A plus minus vector B, which is the same, which means the same. But now I can use the properties of vectors to find vector minus B. And then I will use head to tail technique to draw the vector. For example, in this case, vector A and vector B. What will be vector A minus B? Then, So I will draw vector A. This is my vector A. And how about vector B? I will draw vector B by, let's say, green color. So vector B, I am interested in negative B. And we know that if I multiply this vector B by a negative, the direction will change. So this will be my vector negative B or minus B. So therefore, I will just use the head to tail technique or tail to head technique or method. So again, I will do the same thing. Connect the tail to the head. So this will be my minus B vector. And then now still I am left with one tail and one head. Again, I connect the tail to the head. And this blue vector here represents the resultant vector, which is vector A minus vector B. So in subtraction, we need to use this technique. Another example, vector A minus vector B, draw it graphically. So then, again, I will use the same technique. I will write vector A plus minus vector B. And the reason for writing it in this way is that because I can use the properties of vectors to change the direction of the vector. Okay, then if this is vector B, which is heading up, then minus B will be this. This is minus vector B. So the direction will change in an opposite way, in opposite direction. So now again I will use the head to tail technique to find out the resultant vector. So I will draw a vector A here. This is my vector A, and I will use this equation, which is vector A minus plus minus vector B. So minus vector B is here. So this is minus vector B. And then I have got one head and one tail. So I will connect tail to head. So this will be my resultant vector, vector A minus vector B. And remember, in all these examples that we just draw resultant vectors graphically, we can calculate the magnitude, the magnitude of the resultant vector if the magnitude of each vector is given. For example, this case and this case, just addition, and here is subtraction, as you see. In this case, I use Pythagorean theorem to find the magnitude of the resultant vector if I have already got the magnitudes of A and B each. So I draw it graphically, but we can obviously find the magnitude of the resultant vectors numerically if we have got their numbers. Another property is about vector components. First of all, what does components mean? In the previous cases, if you notice, we were just talking about vectors which were either heading towards right or heading towards up or down. So it means that they were along either x-axis or y-axis. But here in this case, as you see, the vectors have angles with the horizon. And in this case, we will learn about the term which is called vector components. So what does it mean, vector components, and what it means in reality? So if I draw a coordinate axis, x and y axis, so let me select another color. So this is my x and y axis. And I will place this vector A here. Vector A, which has 30 degrees with the horizon. Horizon here is vector axis x. So components is the projection of the vector in each axis. What does it mean? It means that if I come here and look at this vector from this angle, so this is my eyes. So if I look at this vector from parallel to y, so I will see the projection of this vector A on the x-axis, and this is what I can see when I am looking from this angle, parallel to y-axis. Since this projection is on the x-axis, we call it x component. So this will be my AX or x component. Similarly, if I look at this vector from this angle, now let me change, suppose this is my eye, and then I am looking at the vector from this angle parallel to x-axis this time. Again, I will see the projection of this vector on y-axis. So I don't see the size of A. I can only see the projection of this vector, which is not the same as vector itself. So it's only a projection. Since it is on the y-axis, we call it y component. So I will show it by AY. AY means y component. So now if you notice, if I draw a vector in this direction, okay, which is parallel to x-axis, and if I look at this vector from this angle, what I will see, I will see only a dot. So I don't see any magnitude, I don't see any size of the vector, I don't see any projection, I only see a dot. And that means 0. So that means that this vector, for example, vector, let's say vector z, this vector z only has the x component, because if I look at the vector z from the this angle, which is parallel to y-axis, then I can see the vector. Since it is along the x-axis, we can see this vector only contains x component. But in this case, vector A, I can see two projections of this vector. Therefore, it has two components, A y and A x. So now the question is how to calculate A y and A x. I mean the components of this vector on x-axis and y-axis. We use the right triangle simply. So we use the right triangle and sine and cosine. So we define AX with the help of trigonometry. AX as A times cosine 30 degrees. Here alpha is 30 degrees. And vertical component, which is AY, is defined as the magnitude, actually the magnitude of vector A times sine 30 degrees. So this is the way we can find the magnitude of these vector components, the components of this vector. So how about this one? Look at another example. In this example, vector B is making an angle of 60 degrees with the horizon, but with a negative side. As you see, the direction of this vector is towards left. So then we need to be careful. First, we draw the components and we will see how to calculate it. Okay, first of all, x component. So this is my x-axis, suppose, and this is my y-axis, yes? So then I will draw, since the direction of the vector B is towards left and west-north, I just draw the component x in the same direction. Because if I look from above, from the top on this vector, I will see this projection on x-axis. So I will call it bx. And similarly, if I look at the vector from this angle, this is my eye, for example, I will see this projection along y-axis, which I call it, I will call it b sub y. Then again, how to calculate it? Here I need to take into account the direction of the vectors, because we have already agreed on the frame of reference that we agreed on. That means all vectors heading right, positive, all vectors heading left, negative. So therefore, my x component here, the x component of this vector must be negative. Yeah, because it is towards left or to the left or due west. But how to calculate the magnitude? The magnitude, I will write b. X means b, horizontal component is equal to the magnitude of b times cosine 60 degree. And I won't forget to add a negative, because the negative shows the direction of this component. This component is heading left, so therefore we need to show the direction, because otherwise there will not be any difference between case number 1 and case number 2 in x components, because we see in case number 1 the x component is to the right, but in this case is to the left, so we have to put a negative, add a negative behind the x component. And how about vertical component or y component is equal to, since it's towards up or to the north or to the or due north, is positive. So therefore we don't need to add any negative here. So I will write the magnitude of b times sine 60 degree. If we want to be sure about the negative and positive here, if we have doubt and if we want to make sure that everything goes well without our concern, like about should I put negative, positive, and so on, we need to measure the angle from the zero, and the zero begins from here. So if I take this angle, which I will call it, like I will show it by question mark, if I calculate this angle, which is simply, we can calculate it, then I don't need to be worried about minus and positive, because automatically cosine and sine, they will be negative and positive, and they will affect my component. Okay, so next example. Here again, I need to draw first graphically. I need to draw the components, horizontal and vertical components, or x component and y component. So here, this will be my cx, and which is my horizontal component, and the other one, which is along y-axis, must be here, which is my c. I will call it c sub y, c sub y, c sub x, to make it easier for myself to identify the vector components. So in this case, again, I will write cx is equal to the magnitude of whatever the magnitude of the vector c is times cosine 60 degree, and similarly cy is equal to the magnitude of c times but here again I need to be careful, because based on our frame of reference, okay, left negative, down negative, up positive, right positive. Again, I need to add a negative. Let me just write this negative by a different color. So negative c sine 60 degree. In this case also, if I'm concerned about negative and positive and I don't want to be confused, again I need to take this angle from 0 to here. If I calculate this angle alpha, then I don't need to be worried about positive and negative, because automatically sine and cosine, they will include the positive or negative, they will show the correct direction. Okay, so next question is about mixing these two properties that we have learned, addition and vector components. So what if we have some vectors which are not along x or y axis, meaning they have got angles and we are supposed to add them up? How to add vectors which have different directions? That is the question. How can we add up or subtract vectors which have different directions. So in this question, to address this question, we need to use two previous techniques that we have learned in this lesson. And that means, as I see vector A, vector B, vector C, they have angles with horizon. So that means they have two components, horizontal component and vertical component, or X components and Y components. I can break them down into the components. Then all of them either be X or Y. So then I can add up X to X and Y to Y. That is what I can do. So in this case, let's solve this problem. Problem number A, letter A. So I will break A, say AX is equal to A sub naught is equal to. The magnitude is given 10. 10 cosine 30 degrees, 10 sine 30 degrees. Which is equal to 5, 5 and above 10 times 0.8, 86, 8.6. So this for vector A. Sine 30 degrees is equal to 0.5, as you know, okay? And that's why. How about vector B? I will do the same to vector B. B also. This is A, this is B. B component X, B component Y is equal to horizontal and vertical. The magnitude of B times, let me write the formula, cosine 45 degrees, and here is B sine 45 degrees. And okay, 10 times 0.7, let's say approximately. Here also 10 times 0.7. Excuse me. Then it will be 7, 7. So about vector C, again I will split it into two components, which is Cx, Cy, or vertical component, horizontal component. 10 times cosine 60 degree, 10 times sine 60 degrees. And sine 60 degrees is 86. And cosine is a half, 0.5. So here will be 5, here will be 8.6. So as you see now, I can draw the vectors. As you see, all the x, okay, I can add them up together. So I can just add them up. 8.6, and none of them is negative, so therefore I can just simply add them up. 8.6 plus 7 plus 5 is equal to, so this is my resultant, x is equal to 20.6, and my resultant vector component y. I will add up all y components together. So I'll just add them up together, and this will be 5 plus 7 plus 8.6. Let me write it here. 20.6. Then I can just draw two vectors, component 20.6, and this will be 20.6 again. These are my components, resultant components, but the real resultant vector is when I draw this vector, which I will use the Pythagorean theorem, which is, I can find the magnitude of this vector, 2 times 20.6 to the power of 2. I will find it. And how about the angle here? The angle to the horizon that it makes, the angle is equal to tang inverse of 1, which is 45 degrees in fact. So the alpha also will be equal to 45 degrees. So this is the example how to add up vectors with different angles. So the magnitudes also can be different, but this is the general technique. Another problem part B, is quite interesting because this is subtraction, it's not addition, it is subtraction. And as you see, two vectors with a magnitude of 10, 10, we need to subtract them. And so how about this? So in this case, let me draw it one more time here below because there is no space here. So this is 10 with the angle of 60 here, and another one which is 10 with the angle of 60 here. This one is A, this one is B, and then I'm supposed to find out A minus B, vector I minus B. I'm supposed to find out what is the magnitude and where is the direction. So again, in this case, I will use the same technique as we discussed earlier. I will write it A plus minus B. I will write this equation in this way. Then I can draw the vectors. So let's say vector A is the same as, I don't change vector A because vector A must be in the same direction, but vector B, I need to multiply it by negative, and this will give me like that. So the direction will be 100%, 100 degrees opposite. So this is my vector B. Now, this is 60 degrees. This is 60 degrees. Let's add a negative B here because I want to be sure I should not forget. Then I need to just simply find out what is vector resultant vector A minus B or A plus minus B. I can graphically now simply say this is head to tail, so this is vector A. I can move vectors as much as I can keep the magnitude and direction the same. So I will draw vector B here, minus B, and then from this tail to this head, this will be my vector A minus B. This is graphically easy, but I'm interested to find out about the magnitude of this vector. So therefore, I would prefer to first break down each vector into components, and then I add up components to see what is the magnitude of this vector. In this case, just write down very quickly. Let me use another color. Okay. So I will use vector B needs to be broken down into two components, Bx, By, and also vector A, same Ax, Ax, and Ay. Okay. So Bx will be equal to, the magnitude is given 10, 10. So just directly write 10 times cosine. But remember about the sine, cosine 60 degrees. Because my vertical, horizontal component or the projection of this vector along the x-axis is towards left, it's to the left, therefore I need to show the direction by minus here, yeah? I need to show it by minus. By also should be in this direction, so this is B sub y. So it will be 10 times sine 60 degrees is equal to. And in the other case, it will be equal to 10 times square root of 3 over 2, 5 square root of 3. Similarly, Ax, or horizontal component of vector A, will be equal to 10 times cosine 60 degree and 10 times sine 60 degree. Here in horizontal axis or x component of vector A, I don't need to add any minus because both components are heading to the right direction, I mean to the positive, so therefore they both are positive. So here will be 5, and here will be again 5 square root of 3. So then again, I will use the same technique. I will add up x components together and y components together. So a components, if I write, let's call resultant vector again rx, ry, which is my resultant vector. So in x, which is horizontal component, final horizontal component, I need to add up all x components. Here, minus 5 plus 5, which is equal to 0. That means the resultant vector doesn't have any horizontal component. And how about vertical one? Vertical one will be 10 square root of 3, because this will be added up with this 5 square root of 3 plus 5 square root of 3. So therefore, as we graphically drew before, this axis, this vector only has one component, and that is y. So therefore it does not make any it only makes the 90-degree angle with the horizon. So it only has vertical components, and the magnitude we already calculated, which is 10 square root of 3. So that was the example, and that is the answer to calculate vector A minus vector B. Thanks for watching.